Welcome to the Flight Academy Speaking Fluent WAAS online seminar. My name is John Fiskus and I created this course with Luke Lyson. This is the third video in our series. We're going to talk a little about using the 430W to its maximum potential, some differences between the 430W and 430, and how to use the autopilot with these new kinds of approaches. Normally, a WAAS approach will only give you a glide path when your next fix is the final fix. In this scenario, the red line appearing now on the approach plate is the only part of this approach where you'll get a glide path. Obviously, it would be easier for the pilot or autopilot to fly this approach if they could pick up the glide path much sooner than this, because as it is now, we'd have to use the step-down method for each segment prior to that final one. There is a way around this problem, and that is to activate vectors to final once established inbound. This will remove all the intermediate fixes and give you a glide path to follow, seen here as a green line. The glide path will keep you safely at or above all the published crossing altitudes. Make sure you're done with all the procedure turns, holds, DME arcs, etc. before activating vectors to final, as doing that will remove all of those intermediate parts. Another nice thing about WAAS is that the approaches become much more similar. Fly your WAAS approaches just like an ILS and use the same procedures. This is going to go for flaps, speeds, power settings, and procedures for flying the missed approach. WAAS allows more functionality out of our autopilots too. We can now leave the system in GPS steering mode and watch it fly procedure turns, hold entries, and complete holding patterns by itself. This requires no further input from the pilot. Most Cirrus pilots have noted, but it's worth mentioning anyway, that the autopilot in GPS steering mode will occasionally bank steeper than what is needed for standard rate turns if necessary. It will not bank past 35 degrees, so don't let that bother you. We have a few other things to note about using the 430W during a GPS approach. So let's talk about a scenario that's really quite plausible, particularly in mountainous terrain. In this example, we've entered a hold to be used as a procedure turn. In the middle of the hold, it becomes apparent that we need to stay in that hold for one or two more circuits. We might need to do this to lose altitude, to wait for the preceding airplane to land, to wait for better weather at the airport. It could be a long list. Normally, the GPS would cycle to the next fix in the approach upon crossing the holding fix inbound. We don't want that to happen. We want to stay in the hold. So we can reach up and push the OBS button on the Garmin. SUSP, or suspend, will appear just above the OBS button, and the holding fix will stay active. Once the pilot is ready to proceed inbound, he can push the OBS key again. The GPS will now cycle to the next fix when the airplane passes the holding fix inbound. Here we're going to demonstrate a characteristic of the 430W that users of the traditional 430 might find different from what they're accustomed to. In this video, we've loaded an ILS approach, and you'll note that upon activating the approach, the CDI will switch immediately from GPS mode to VLOC mode. So let's watch that happen. Traditionally, the CDI would not automatically switch to VLOC until the airplane was inbound on final, but here it switched right away. So here we have that situation again, but with a minor difference. Notice the frequency, which is not an ILS frequency, is in the active VLOC position. As you can see, if you don't have the right frequency in the active spot, the CDI will not automatically switch to VLOC and suspend mode will show up. And this will stay that way until the appropriate frequency is in the right spot. So why did that happen? Traditional 430 users who are transitioning to a 430W will notice that this is different from what they're accustomed to seeing. As shown here, an activated vector to final approach will show up as suspended initially. This is because certain criteria must be met before the Garmin will allow it to continue sequencing. The criteria is going to be demonstrated next. So here they are. First, the airplane needs to be on the to or approaching side of the final approach fix. Next, the airplane must move within the corridor shown on the picture to the right. The corridor is a 45-degree angle off the final approach fix. Once the airplane enters this cone, suspend will disappear and the Garmin will sequence normally. Legally, you must fly within these gates. Garmin just made an extra step to help ensure pilots and controllers couldn't shortcut and get themselves into danger. As an added bonus, WAAS allows us to file to any airport which has only GPS approaches as an alternate. Before WAAS, we couldn't do that. Another nice benefit is WAAS allows us to file and fly T routes, shown here in blue. These are GPS-only airways. They often allow us to take shortcuts and fly lower than on normal airways between VORs. Also available are Q routes, which are high-altitude GPS airways. That concludes this segment of our Speaking Fluent WAAS seminar. Tune in for our next video, which is going to talk about staying safe while filing with a WAAS-equipped airplane. Thanks.